Hey, sixth grade. How are you doing? It's Mr. Dreisbach. I'm happy that you're watching me right now. If you're watching me right now, you've already done a lot of great things for what will be your second day at SCH at home. If you're watching this, it means it's Tuesday, April 1st. Hopefully you've gotten a message around 9:30 from Mrs. Pino talking about how things are. Then after that, hopefully you had a nice Google Meet time with your advisor, checking in, seeing things, and then you started your Tuesday sort of first period time of work, which is science, and you clicked the right links to find the right place that you got to this video. So if you're here, awesome. I'm glad to have you here. Where here is, for me, I'm actually in my guest room in my house, which is a little bit nice and quiet. And I will be making videos from here in the foreseeable future. From here, I will be checking in with you and preparing things for you and making more videos like this for you and helping you as we move through this online experience. One of the things I wanted to do first is to kind of reintroduce you to haiku. One of the things we'll be using a lot is our haiku site. Now, we've been here before. Remember, we used it for rocks and minerals and plate tectonics and geologic time. We've been there before, and now we are in meteorology. So this meteorology page is where you'll be. This video that I'm making right now will also be linked on this page. It's not there yet because I'm still making the video right now, but it will be there. What I want you to do today is first watch this whole video. After I talk and do this intro, I'm going to go over all of our class notes on meteorology. High, low pressure systems, warm fronts, cold fronts. So I want you to watch that with your notes in front of you, just as a refresher to kind of knock off the long spring break cobwebs and get reacquainted with the ideas that we've explored so far in meteorology. Then I want you to watch this video, What Are Weather Fronts? It's another kind of refresher video going over those things. And then I want you to do a homework assignment, essentially. But it's a little different than before. In the past, I'd give you a handout that you'd use your book and you'd write the answers to. Here, actually, you'll get the handout, the homework assignment. You would click it right here on haiku. When you open this, you would see, here it comes, a page. This is your homework. But you'll have to do it on Google Docs. You'll have to edit this document. Come on, document. You'll have to edit this document. Here it comes, to make it work. You'll have to make a copy of your own. We'll say File, Make a Copy. The version you're going to look at, you can't write on. So you'll do File. Here we go. Make a copy. When you make a copy of the homework assignment, that copy you can write on, and that will do your work. And you can save it in a folder that you like, and from there you can make your work with that. Now, once you answer those questions, you'll use the textbook reading. Now, hopefully you have your textbook, you brought it home, but if you forgot your textbook or it's not with you, you can click this link, which is a PDF version of just the pages you need to read to do this assignment. So you read this little chapter, answer these questions, and when you're done with that document, instead of handing in the homework by paper like you used to, you'll hand it in right here. Here's the assignment. It's due the fall. It's due tomorrow. And for me, it says view work, but you'll see something that says hand in. If you click hand in, it'll tell you how to hand in a Google Doc. And from there, I'll be able to see all of your work. Now, that was a lot of information. If you need to, just hit pause and go back, and you can hear me say it again. If you're still having some trouble, always feel free to email me. I'll be checking my email a lot during these days. So please feel free to email me, certainly if you have a problem during this time. All right? Oh, all right, we'll get that out of the way. All right, so we're going to go over our notes. Here's our notes packets that we started, gosh, it seems like such many weeks ago. It was many weeks ago. So the first thing about meteorology, we talked about the atmosphere, the layers of the atmosphere, and thinking about how we actually live in sort of an ocean of air. And we're down on the bottom of this ocean, and the atmosphere has these different layers. We don't need to know much about those layers. The main thing is that we're in the troposphere, where all of the weather that we think about all happens here within the troposphere. The stratosphere has the protective ozone layer, and even layers of the atmosphere like the thermosphere, that's where the space station is moving above us. It's actually still in part of our atmosphere, believe it or not. Those are the different layers. And we had a little graphic here to describe those as well. Now, an important part about layers of the atmosphere, the big idea is that air is stuff. Air is made of molecules, and that stuff is being pulled down to the surface of Earth by gravity. Therefore, air has weight. Air right now is pushing down on me. It's pushing down on you. It's pushing all of that. And what you feel, when you feel that weight collectively, that's what we call air pressure. All of us is always feeling air pressure on top of it. To kind of look at this idea, we did a couple different demos to show that air has more weight. We blew up the two balloons here, and the one with more air had more stuff compact in it, and so it would weigh a little bit more, and we saw the scale down there. We did this little demo too where we put in water. Now, we're talking about air here, we're talking about water. The same idea that there's more pressure at the bottom of a container of water than at the top, and you can see that pressure kind of be released when you open up all three of these outlets, and the water came out much faster at the bottom than it did at the top due to in this case, due to water pressure. Less pressure at the top of the bottle, like there's less pressure at the top of the atmosphere, more pressure down low. We looked at crushing a can. Now we got into a little math. Let's not worry about the math right now, but this idea of if you change the air pressure of two different areas, air pressure is always trying to get from an area of high pressure to low pressure. A big idea from this is air is always trying to move from an area of high pressure to an area of low pressure. So if there's more pressure inside the balloon, air pressure, than outside, that air will try to get out if it can. We were able to blow up a balloon on the inside of a bottle by decreasing the air pressure on the inside. The outside greater air pressure pushed in to increase that. And again, this idea that there's more air pressure at the bottom of the bottle, bottom of the atmosphere, than at the top of the bottle or the top of the atmosphere. There's less air pressure the higher up you go. Oh, and we did this little activity too. We played around with a straw as well. Oh, yes, and there was our classroom barometer. That when the air pressure increases, it pushes down on the liquid to make the liquid go lower and lower. High air pressure would show on this device, on this barometer, that the water level would be lower. When the air pressure outside gets lower and lower, when we get lower air pressure, this column of water is able to go up because now the air pressure on the inside of the barometer is greater than the outside, can push the water back up. I wonder how that barometer's doing. It's sitting in our room, lonely. Anyways, back to pressure systems. Okay, now, one of the things to think about is that how these pressure systems occur, we have to think about how air is not always the same temperature. Because of uneven heating of the Earth, parts of the Earth are warmer than other parts. Parts of the Earth are colder. And because of that, warm air can spread out, warm air becomes less dense and it starts to rise up. Cooler air condenses, becomes more dense, and sinks down. So air can expand and become less dense and rise up. And then it can cool down and condense and get denser and sink down. And this creates a pattern called a convection current. I should say it creates a current. Condenses, sinks, expands, warms up, goes up. And that convection current is important as we think of it in terms of air. Warm air can rise up, cool down, and then sink, and then warm up and go up. And these convection currents are what creates the wind. If you are outside on a windy day, you are at the bottom of a convection current. And then we looked at, did we look at it here on the next page? Yeah, we looked at it here. If you are in a place where air is falling down on you, if it's being pushed onto you, you're feeling more air pressure. It's being pushed down on you at this side of the convection current. That area would have what we call a high pressure system. There could be areas where the air is being lifted up. It's kind of rising up off of the area of the Earth, and that would be a low pressure system. In this example, if there's a city A and a city B, and there's a big convection current going on, with warm air rising up off of this city, and cooler air, condenser, coming down on top of this city, city A would experience a low pressure, and this city over here, city B, would experience high pressure. We'll see these big L's and H's pretty soon when we look at our weather maps. And there we are in the middle of the two cities. Here they are between an H and an L. There we are, feeling a lot of wind. Another thing associated with this is that with low pressure, as air is rising up, when warm air rises, it condenses and becomes cooler, and it releases the water that's in the air to form clouds and rain and things like that. When there's high pressure, because the air is coming down, pretty much means that there aren't clouds forming. Low pressure system is what forms clouds, could be storms, certainly rain. High pressure system is essentially the absence of that. There are not the formation of clouds during high pressure systems. So this pressure difference can tell us a lot about what the weather is. Is it going to be cloudy or sunny, or could it be stormy or sunny? Those are things that the low or high pressure systems can tell us. Now, why is it that this warm air suddenly makes clouds? Has to do with humidity and how much water the air can hold. So if you think of just these air molecules, we drew this up there as air, in between the air molecules that are warm and spread out, you can hold water molecules a little bit easier. But if this air that's holding these water molecules suddenly cools down, and the air molecules cool down and come closer together, there's no more space for those water molecules to exist. So they come out of the air in the form of liquid. They condense, essentially. The water condenses and creates little rain droplets, or create little cloud droplets to make a cloud. And those cloud droplets get big enough they can create rain droplets, but then fall to the earth. So when this colder air can no longer hold as much water, that water condenses to form clouds and rain. And that leads into, could be putting this together, how could this then lead into different types of weather? So the next part of this notes was the air masses and fronts. Air masses and fronts, we talked about how there are essentially two variables of which we can categorize types of big chunks of air on the continent. Air can either be cool or dry, and air can either be, it can be cool or warm, and air can either be dry or wet. So it can either be dry, there it is, the humidity can determine, let me back up. An air mass can also have, in terms of temperature, can either be cool or warm. You can have cooler air or warmer air. And you can also have drier air or kind of wetter air. And humidity is how much moisture is in the air. So you can have like kind of humid air that's filled with water in it, kind of a sticky humid air, or a dry air. The combination of these two variables gives us sort of some basic types of air masses. You can have cool, dry air, or you can have cool, wet air. You can have warm, dry air. You can have warm, wet air. And those form the four basic types of air masses that we'll think about. And where do they come from? We can think of it in terms of this here, that colder air is coming from the north. And if colder air is coming from the north over land, it's not over water, it will be cold and dry. If colder air is coming down from the north, but it's coming over the wet ocean, it can pick up moisture, so you can have cold, wet air masses coming down from the northwest and the northeast. Reversely, warmer air that's coming up from the very warm equator, if it's coming up over the land, it can be warm and dry, like in this part of the United States, over Mexico and into Arizona and New Mexico. Or warmer air can be coming up over the ocean, either the Gulf of Mexico or the Atlantic or the Pacific. So we can have warm, wet air masses coming up in there. Now these air masses don't always just stay where they are. They're always kind of fighting each other. The cold air mass is coming down or the warm air mass is coming up. And they kind of bang it all out. They punch each other through with us right here, the United States. And when we notice where those air fronts are coming in, when they're moving, the front edge of an air mass is called a front. These air masses don't stay still, they move through. If a cold air mass is coming in, it's led by what we call a cold front. Or if a warm air mass is coming in, it's known as a warm front. Cold fronts are drawn by this sort of blue, typically blue for cold, line with these sort of teeth arrows to show which direction it's going. Warm fronts are typically drawn in red for warm, and warm fronts, because they don't bite as much, so to speak, as a cold front. Their teeth are kind of round, but they can again sort of show you the direction. Sometimes these two fronts can kind of get stuck together to create a stationary front, where they're both kind of just locked, not really one overtaking the other. They're just stuck together, they're stationary. And sometimes you can have an occluded front. We're not going to worry about too much of an occluded front that much, where one can sort of overtake the other. Importantly, though, it's when warm or cold fronts move through that you can get associated weather. So the first one, if a warm front moves through, warm air comes into the area. In this example, warm air, by the shape of this line, is moving up in this direction. It's coming from city A, heading towards city B. Warm air, when it's moving in, sort of slowly lifts the air up. That warm air cools, condenses, and can create long big clouds that can cause lots of rain over a longer period of time. Warm fronts can bring extensive hours, if not days, of rain, and of course bring warmer temperatures. Cold fronts are a little different. Cold fronts come in. Cold fronts typically move a little bit faster. They bring colder temperatures. And when they come in, because they come in so fast, they just sort of push, bammo, push up all the warm air that's in their path. Because they're pushing up the warm air so quickly, that warm air quickly rises and creates much bigger clouds, bigger storms, especially during the summertime. If you have a really hot, humid day and then a cold front barrels in and knocks all that hot, humid hot, humid air up into the atmosphere, that hot, humid air can create thunderclouds, big storms, tornadoes, things like that as well. That's what can happen with a cold front. Again, when you have an occluded front, well, there could be something where they kind of get, one sort of overtakes the other. You can have some clouds with an occluded front, but don't worry so much about them. And lastly, a stationary front. There isn't much movement. The key idea about a stationary front, not so much about what kind of weather could be happening. The main thing about a stationary front is that it probably means that the weather's not going to change because the two fronts are sort of stuck in conflict with each other. I think that extensively is where we ended up, and that's good for today. It's a lot of notes from there. All right, you've made it this far. I hope that was helpful. Now, for a little extra refresher, go watch that other video, this video right here. And once you're done with that, open up your textbook and work on these problems with this reading. I think that'll be plenty enough for today. Good job for you. Email me right now if you have any questions while you're watching this. My office hours too, so to speak, are also in the afternoon. I'm going to be online on my computer. We can check in by email, or we can check in if we want to do a Google Meet if you want, from 2:30 to 4:30. I'm available as well, so I'm always happy to be there for you. I hope you're all doing well, and we'll see each other soon. Bye.